So this week we are starting our unit on statistics. To start off the unit, we're going to be looking at some different representations of ways you can display data in a graph. Today we're going to be focusing on a histogram. So let's start with filling in the blanks. A frequency table is a chart that indicates the number of values in each interval. A histogram is a graph that uses bars to display numerical data that have been organized in a frequency table. It is similar to a bar graph but does not have spaces. A distribution of data shows the observed or theoretical frequency of each possible data value. What the heck does that mean? Okay, observed or theoretical frequency, frequency meaning how many times it shows up. So it's an observation if you see it showing up, like you're rolling a die, and how many times you observe the 2 showing up on the die, or how many times you observe a 4 showing up on a die. Theoretical is what you would predict it to be, how many times you think it would show up. If you rolled the dice, how many times you think the 2 would show up, how many times you think the 5 would show up, and so on. So you would expect if you're looking at a die that since it's got 6 sides, it would be 1 out of 6 for each of the numbers. That's theoretical. Observed is when you actually do it and you figure out how many times it shows up. All right, so you've probably done graphs like this before, but you've never seen it in this way. So we have some examples of different types of histograms. These are some different histograms being displayed. And we're going to be talking about their distribution and how that affects the measures of central tendency, which hopefully you remember as the mean, median, mode, and range. The mean, remember, is the average. Median is the middle. Mode is the number that shows up the most. And the range is how far apart the lowest and highest number are. So you could have a histogram that looks like this first example that is symmetrical. Now, not all are going to be perfectly symmetrical like this one is, okay, but they will have a symmetric appearance in that it looks like the halfway point would be about here, and both sides of my blue line are symmetric to each other or close to symmetrical, okay, where the highest point is in the middle. So this data are evenly distributed. The mean and median are about the same. So if you were to calculate the measures of central tendency here, the mean and median would be super, super close because the data is evenly spread. Negatively skewed looks like this, and the majority of the data is on the right, on this side, but it has a tail to the left, which indicates possible outliers, and the median is a more accurate measure as the mean will be pulled down. So these lower numbers down here are going to pull down the average, making the median a better representation of the data. And then we have positively skewed, and that's when the majority of the data is on the left, like this here, and it has a tail to the right, indicating possible outliers that are on the higher end. And the median, again, is a more accurate measure as the mean will be pulled up. So the mean is going to be pulled up by these higher numbers here. So the median acts as a better representation of the whole lot of data. Okay, so let's practice creating these histograms. So we have ages in the United States. So here are how a frequency table would be set up. So we have ranges here, 0 to 10, 11 to 20, 21 to 30, and so on, without a gap in between. So we're not going to be talking about 10 and a half or 20 and a half and so on. You're just rounding to 10 or rounding to 11 based on the age. So in our frequency table, we have those ranges, and then we have the percent of the population which falls into those ranges. So we're going to create a histogram. So our charts aren't set up, so we're going to draw our X and Y axis. Our Y-axis in this case is going to be the percent of the population. And our X-axis is going to be the ages. So now I have to figure out how am I going to split up this data so that it all fits on my graph. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 categories. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 boxes. So right there, that tells me that I can make each category be 2 boxes long. So I'm going to split it up so that from 0 to here, represents 0 to 10. Then the next two boxes are 11 to 20. The next two boxes, 21 to 30, and so on. Okay, so we have all of our categories set up. And now we are to figure out how we're going to set up our y-axis. So if I'm looking at my y-axis or my y column, the highest percent of population is 14%. So I have to get as high as 14 to make this fit. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 boxes exactly. So we can count by one here. So I'm going to label every other one just so it's easier when I'm graphing. And now I can start making my histogram. So when you're doing this, you want to be super neat. If you're not using a ruler, use some kind of straight edge or just be super careful when you're graphing it. So 0 to 10 is going to go all the way up to 13. We're going to create our first bar. Now when I do this, since you'll be using pencil sometimes, it's nice to shade it in opposite directions for each bar so that each bar stands out. So there's my first one. And then 11 to 20 would be 14. I'm going to shade that in the opposite direction so it's clear that that is different than the first bar. Then 21 to 30 is 13 and a half. Then 31 to 40 is 13.
District Valencia, please contact main office.
Then 41 to 50 is 14 again. '51 to 60 is 13 and a half again. So we're seeing that the population of each age group is about the same. And then 61 to 70 goes to 9. Oh, my color keeps changing. '71 to 80 to 5 and a half. '81 to 90 to 3 and a half. So now we're seeing changing in the heights of these bars, so it's not that each bar is so close anymore, and 91 and up is only 1%. Okay, so that is what a histogram looks like. We can now talk about this histogram as being either symmetric or skewed. In this case, because there is not a peak in the middle and the numbers dip down on this end, we could talk about there being a tail here. So this is what we would call positively skewed. So the median is more representative. As the older ages will pull up the mean. Okay, so now you're going to try the ages in Kenya on your own and make a statement about that distribution as well, and then answer the questions in your Go Formative before starting tonight's homework.